Alright, good afternoon, pre-calculus students. So this one, it's for chapter 3, Polynomials. So this one is part 1 of the lecture. So this one will cover the James Stewart textbook 3.1, 3.2, 3.3. So it's about the polynomial function of a higher degree. So the way to find a zero, the way to find the maximum minimums, the end behavior, and also the way to use the P over Q, the rational zero theorem, to identifying that all the possible rational zero or the irrational zero. Also, I'm going to be showing that using the graphing calculator or using decimals. Okay, so we'll take a look at that. So started off with the first part of the lesson. So determine the end behavior of each polynomial by using the leading coefficient test. State the degree and the highest number of possible real zero. So if you just record things that we talk about in Algebra 2 trig honors. So the way to find out the number of possible zero, it's by looking at the highest degree. Okay, so this one basically gives you 5. So it looks like we do have 5 zeros. But now we need to find out the possible zeros. Okay, so let's state the highest degree number first. So the highest degree is 5. What does that mean? It's 5 real zero. It could be 5 real zero. It could be 3 real zero. It could be 1 real zero. But according to the given graph, this one we do have 3 real zero. So one is that in between -2 and 0. So this one, it's somewhere around that -0.8 something or -0.9. Okay, so that's considered 1 real zero. And also we do have a horizontal tangent of that above right here. So this one would be another 2 real zero. And you might be wondering, it's the same solution, but the thing is that the multiplicity. So the multiplicity here, then that would be 2. Because that is considered the horizontal tangent. So somewhere around 1.5. So we're going to end up with two identical real zeros. Okay. And for those people might be wondering, can we either simplify this one by using factor by grouping? I mean, you can do it that way as well. But the thing is that all the zero here, most likely, they're considered irrational numbers. Okay, irrational number, that means it's going to be considered the non-terminating decimals. So another thing is that you want to determine the end behavior. So this one, as x goes to infinity. So this one, according to that arrow, y goes to infinity. And also by looking at the graph here, as x goes to -infinity, and then y goes to -infinity. Another way you can test that out is by using the highest degree term, 3x to the power 5. So you plug in infinity to that x right here. So we got 3 times infinity to the 5th power, which is 3 times infinity. So that would be infinity. And then plug in that -infinity. So 3 times -infinity to the power 5. So 3 times -infinity, then that would be -infinity. So either you can just determine the end behavior by looking at the graph, or you can determine the end behavior algebraically. And also the leading coefficients, so this one is 3. So positive, that means x goes to infinity with the odd degree. So y goes to infinity. And then, again, same coefficients with the odd degree. X goes to infinity, y goes to -infinity. Because the power, it's odd, and also the coefficient is positive. So we got 3 real 0 here. And for those you might be wondering, what about the rest of those 2 zeros? Well, they consider imaginary numbers. Okay, we'll talk about the imaginary number in the next part of the video. And now, what about for part B? So this one is an M curve. So you count up the highest power here. So we got 2, 1, and 1. So the highest power, then that'll be 4. So the highest degree. So this one is to the 4th power. And let's find a 0. So at 1, so this one appeared twice, because that's the multiplicity. And then at -2, so this one just appears once. And then at 4, that only appears once, because it just crossed through, the graph just crossed through the x-axis once. Okay? So we got 4 real zeros. And what else? What about the leading coefficients? So leading coefficient is negative. So negative x times x times x. Well, negative x squared times x, negative x to the fourth power. So this one, just analyze it. So x goes to infinity. So y goes to negative infinity. Well, the reason why that is because that y equals negative times infinity, quantity to the fourth power. So it's negative infinity. And then the other directions, according to the graph here, so x goes to negative infinity, and then y goes to negative infinity as well. Again, plug in a number, infinity, to the end behavior, negative x to the fourth power. So y goes to negative times negative infinity, quantity to the fourth power. So negative infinity, quantity to the fourth power, that's infinity. But there's a negative sign right in front of it. So that's why it's negative infinity. So it's an M curve. And you might be wondering, what about the bumps? The maximum, minimum. We'll talk about that later for the next one. So for number 2, you want to determine whether f it's even, odd, or neither, and then find its maximum or minimum value. Okay, so it looks like this one, it's going to be like a W curve. Again, by using the leading coefficients and the highest degree rule, so fourth power, so either it's an M curve or it's a W curve, because it shows 4 different changes. Now the things that the leading coefficient is positive, so we're going to find out the M behavior, and also we're going to determine the maximum and minimum. Okay, so now let me just snip this one. Okay, so I'll put it to a new slide here, the active inspire. Okay, so now according to the pattern here, so it looks like this one is kind of like a quadratic pattern. It's an even power. So for those you might be wondering the way to find the max and the min, we'll deal with that later. Okay, so that's what we need to do, word problem. So the first thing that we need to determine is the function, whether that's odd, even, or neither. So in order to prove the function is even, so we need to show that f of x is the same as f of negative x. If the function is even. If the function is odd, that means we need to prove that f of negative x is the same as negative f of x. So neither, that means none of those functions match with the other one. Okay, so let's find out. So let's start out with f of negative x. So for f of negative x, we do have negative x to the fourth power, negative x quantity to the fourth power, minus 2 times negative x quantity square plus 4. Even power, so negative x quantity to the even power, 4th degree, it's the same as what? X to the 4th power. This one too, so negative 2x squared, so negative x quantity square is still considered positive, so positive times negative is still negative. So this one basically just matches up with the first one, the original function. So therefore f of x, it's even. Okay, so f of x, it's an even function. Another way you can determine the function is by looking at the power for each term. So even, and then the power here is like x to the power of 0. So if all the power for the terms even are considered even, so that means the function must be even. So f of x, it's an even function. Now the next thing that we need to find out is the maximum, minimum. So the way to find out the maximum, minimum, so pretend this one is like a quadratic equation. So the way to find out the vertex for the quadratic equation is always consider x equals negative b over 2a. So basically for this one, we can just put in that x to the power of 4, it's like x squared, quantity square, minus 2x squared, and then plus 4. So solve for x squared first by using the vertex formula. So what we got here, so is x squared equals negative b, so which is negative 2, divided by 2 times 1. So what we got here is 1. So x squared equals 1, so that means x got to be plus minus 1 for those for the vertices. Okay, so one thing at a time. So start with that x equals 1. Let's find out the y value. So when x equals 1, so y equals 1 to the 4th power minus 2 times 1 quantity square plus 4. So y equals 1 minus 2 plus 4. Then that will be considered 3. So we got 1 comma 3. And what about at negative 1? And since we do know the function it's even, so that means it's symmetrical with respect to the y-axis. So that means at negative 1, so it's the same result. It's going to be 3. So let's just verify it. So negative 1 quantity to the 4th power minus 2 times negative 1 quantity squared plus 4. So 1 minus 2, negative 1 plus 4. So it's 3. So we got negative 1 comma 3, 1 comma 3. So 1 comma 3, obviously, well, this one is one of the maximum. Negative 1 comma 3, that's another maximum. Now, what about for the minimum? The minimum is just the average value between those two maximum. So plus minus 1. So the way to find the average value, so basically we just want to combine those two numbers together and then divide it by 2. So x1 plus x2 over 2. So negative 1 plus 1 divided by 2, so we got 0. So that means the minimum, it's going to be right at 0. So let's find out what that is. F of 0. So for f of 0, so we do have 0 to the 4th power minus 2 times 0 squared plus 4. The y-intercept, which is 4. Okay, so 0 comma 4. And this one, oh, you know what? It's a W curve. So for the one that we found earlier, 1 comma 3, negative 1 comma 3, those are the minimum. The reason why that I do know that's a W curve, because that x to the 4th power with the leading coefficient is all positive. So x goes to infinity, y goes to infinity. And then x goes to negative infinity, y goes to positive infinity. So for the one that we found on the y-axis, so this one is supposed to be the maximum. And then those two number right here, the bumps, so negative 1 and 1 at 3. Okay, so it's a W curve. The way that I make the graph here is just like a rough sketch, but by the time they plot the point, you'll see that once you connect them. So decreasing, increasing, and then decreasing, increasing. So 4 different changes, because that to the 4th power. Okay, so for the one that you want to stay here, so the minimum, and then the maximum. Okay, so now let's see what else that we have for the template here. Okay, so the next one, this one might be a little bit challenging, so we need to find out, looks like we need to find the value of k, or the value of k that's given already. Okay, so let's check it out. So number 3. So again, this one is nothing new, nothing special, so the way that I put it here, so it might be a little bit complicated compared to what we did in Algebra 2. So I just want you guys to think about it outside the box, okay? So some of the problem might be considered kind of a critical thinking one. Okay, so you need to think about out from the box. Okay, so here we go. So f of x. So this one is a little bit abstract. We don't know the value of k, so it's x to the 3rd power minus kx squared. So g of x, that's a quadratic. So that one is a pure quadratic functions for g of x. So find the point of intersection, or intersection of points of f and g. So anytime they want to find out the point where they intersect, so that means the y value got to be exactly the same. So the way to do it, and also the x value got to be the same as well. So what we can do, we can set that f of x equals g of x. Now since we don't know the value of k, we cannot just put in the functions to the calculator, so we have to do it manually. So x to the 3rd power minus kx squared, so that equals x squared. And for those you might be wondering the way to solve to find out the point, the xy value. So here's another thing we can do. So since they both share with the exact same x-intercept, or the exact same y-intercept, because that by the time you plug in 0 for x, so y equals 0, and then by the time that you plug in 0 for g of x, so y, g of x also is 0. So 0, 0, so that's considered one of the point of the intersection. But this one's a plural, so let's find out that in general. So to solve for x here, so what we got, it's x to the 3rd power minus kx squared minus x squared. So that equals 0. And now from here, we want to take out the greatest common factor. So take out the greatest common factor. What we got here, it's x squared. So we got x minus k minus 1. So for x equals 0, we found it. So that's one of the zeros. So that appears twice. So that means at 0, it's going to be considered a horizontal tangent, or it's going to be, there's a bump at 0 there. And then what about the other solution? So the other solution would be considered x minus k minus 1 equals 0. Solve for x in terms of k. So that means x equals k plus 1. Okay, so this one appears twice. Multiplicity. Make sure that you state the multiplicity. Very important. And this one, that just appeared once because that's linear. So for part B here, let k equals 2 on the same Cartesian plane. Sketch the graph of f and g. So if k is 2, so we got f of x. So that equals x to the third power minus 2x squared. And then g of x, just x squared. While g of x is x squared, that's just considered a parabola. Okay, so parabola, so 0, 0, and then 1, 1, negative 1, comma 1, and then 2, 4, negative 2, comma 4. So what I did here, just like a mental XY table. Okay, so simply connect those dots for the parabola. But make sure that you need to extend it all the way through. So at 3 square, then that'll be 9. Okay, so negative 3. So y is also 9. So started off with this basic function, the parabola. And now we do know this one's going to be a cubic curve. Find a 0. So factor it, set that y equals 0. So we got x squared equals x minus 2. So we got x equals 0 twice. Again, multiplicity. And then x equals 2. So 0, 0. So that appears twice. And then at 2. Another thing that I might be considered doing here, besides finding the zeros, so you might want to find out the points right between those interval. So the points right between, so let's say that xy table for x equals negative 1. So negative 1 quantity to the third power, that's negative 1. Negative 1 quantity squared, that's 1 times 2. So negative 1 minus 2, which is negative 3. So negative 1, comma, negative 3. And let's see what else that we got here. And the number right between 0 and 2, 1. So 1 cubed, then that's 1. Minus 2 times 1 squared, minus 2. So negative 3 again. So 1, comma, negative 3. So make sure that you guys plug in the number correctly, because otherwise that would turn out to be something else. And now let's put in a fraction and see what happened. Because it looks like there's a bump right between, well, let's see, this one's a horizontal tangent. So this one should be fine. So it looks like there's a bump right between 1 and 2. Okay, so 1 and 2, so let's find out 3/2. At 3/2. So using that, the factor form, so 3/2 quantity squared, so we got 9/4. 3/2 minus 2, which is considered negative 1/2. So we got negative 9 over 8. So this one is about negative 1 point something. Negative 1.18. Okay, so somewhere there. So eventually the graph is going to be like this, increasing, and then at 0 here, that's a kind of like a bump, because that's a horizontal tangent at the 0 due to the multiplicity. So it's a horizontal tangent. And then the rest of this, it just makes the turn and then goes back all the way to the top. So one is considered a quadratic, so it's a U shape, and the other one is a cubic curve. And try to verify the AND behavior. X goes to infinity, y goes to infinity for the cubic function. And then as x goes to negative infinity, y goes to negative infinity. So it shows the arrow. Okay, so another part right here. So for k equals 2, solve the inequality for g of x is greater than or equals f of x. Okay, so this one is just like going back to what we did for the previous unit. Okay, so set those two functions. One is greater than the other. So x squared is greater than or equal to x cubed minus 2x squared. So again, bring everything together to one side. So negative x cubed plus 2x squared plus x squared. Then that's plus 3x squared. So it's greater than or equals 0. So what I did here, I just took the left element, all the element from the left-hand side to the left-hand side. And then the rest of this, convert that to its positive. So x cubed minus 3x squared less than or equals 0. So factor it and then find out the possible 0, do the sign tests, and then you'll see that the inequality at which area it's considered less than 0. Well, actually this one is quite obvious. So it's just like using the graph here. So anything that from negative infinity to 0, so g of x is greater than f of x. Greater than or equal to f of x. So negative infinity to 0. Just by looking at the graph, you can see that from here. Again, it's about the x value. And then also right here, so it looks like this one is going to go through. So you need to find out the possible 0. So it looks like f3, we're going to pass through it. So anything that from 0 to 3. Okay, so 0 to 3. Okay, so that's also considered for g of x is greater than f of x. Another way we can do it algebraically. Okay, so find out the possible 0, factor, and then set up the line test. Find out which part that is considered less than negative. Okay, so now going back to the template. Okay, let's see what else that we have. And this one is quite similar to what we did in Algebra 2. So find a polynomial function whose zeros are negative 3, so x plus 3 for one of the factor. 1/2, so x minus 1/2. And then the conjugate, as you can see that negative 2 plus root 3, negative 2 minus root 3, those are the conjugate. So it's x minus negative 2 plus root 3. And then times the quantity, x minus the quantity of negative 2 minus root 3. And then the rest of this, you just want to FOIL. So this part right here, the first two binomial, you want to FOIL. And what about the second, the third, and the fourth binomial here? Well, this one is the difference of 2 squared. You can regroup them. So x minus plus 2 minus root 3. And then x plus 2 plus root 3. So using the difference of 2 squared pattern, we do have x plus 2 quantity square minus root 3 times root 3, root 9, which is what? 3. And then this part right here, simply just FOIL. So first, outside, inside, and then last. And then the rest of this combined like term. Factor, while this one just expanded, binomial expansion, combine like term, and then FOIL that again. So x squared, negative 1/2 x plus 3x. So this one turns out to be 5/2 x. And then minus 3/2. And this part right here, expanded, so x squared plus 4x. 2 squared 4 minus 3, so plus 1. And then the rest of this trinomial multiplied by the trinomial. Okay, so simply just multiplied it out, distribute, combine the like terms again. And the next one, it's a new theorem. I think we talked about this a little bit in Algebra 2. It's called the IVT. It's called the Intermediate Value Theorem. So what this one is saying that if f of a does not equals f of b, then in the interval in between a and b, the closed interval, including a and b. So f takes on every value between f of a and f of b, provided that a is less than b. It is. So let's say a is negative here, so b is positive. For all the real number, so a is less than b. If you see the symbol like that, like an upside down a, and then the unshaded r, so this means that for all real number. Okay, so for all real numbers. So for c between a and b, so the value between a and b, it must be at least one c, such that f of c equals w. Well, there's going to be at least one c right in between. It is, because this one is higher, this one is lower. So the one that for c, so it could be this one right here, or it could be this one right here for the 0, or it could be the 1 right here. There's so many c's right in between. Okay, so the c is saying that it's like f of c equals 0. Okay, so w, that's just the number for the y value, but normally this one is describing the zeros. So 1, 2, 3, the zeros right in between. So now let's do one example. So something that's similar to the intermediate value theorem. So, and you want to locate the smallest interval, which consecutive integer endpoints. Okay, the interval, consecutive integer endpoint, in which the zeros of f of x, x to the third power, minus 3x squared, minus 2x plus 1. Okay, so we just want to set up the intervals for the value of c. Now this one obviously is non-factorable, and for those who might be wondering, can we use that the p over q theorem, the rational zero theorem? I mean, we can try. So p over q, so for the value of p, then that's 1, the constant, and the value of q, the leading coefficient, which is 1. So plus minus 1 over plus minus 1, then that would be plus minus 1. And then using the synthetic division to verify it, so we got 1, because that's 1x to the third power. And then negative 3, so minus 3, negative 2 from the greatest power to the least, and 1. So let's try negative 1 first and see what happens. First number, bring it down. 1 times negative 1, negative 1. Combine them, negative 4. Negative 4 times negative 1, positive 4. Combine it with negative 2, 2. So 2 times negative 1, negative 2. Well, this one doesn't work. In order to get this one going, so the final remainder must be 0. So what about if we try something that's considered, well, the other number that we haven't tried yet, so this one is what, 1. Let's try 1 and see what happens. So we got 1, negative 3, negative 2, and 1. First number, bring it down. 1 times 1, 1. Combine it with negative 3, so we got negative 2. So negative 2 times 1, negative 2. So negative 2 plus negative 2, negative 4. Negative 4 times 1, negative 4. So it's negative 3. So you try to use the rational zero theorem. None of those possible solutions work. Because those zeros, they might not be considered rational. They might be considered irrational. So in order to say that this one is true, so let's plug in a number to verify the consecutive integer endpoints. So this one basically can say that the function is continuous from negative infinity to infinity, because that's a polynomial. So for the zeros, well, it's hard to tell. But the things that we can put into the decimal and find out exactly so where that it's in between. Okay, so the interval in between. So x cubed minus 3x squared. Okay, so using that decimal. So y equals x cubed minus 2x squared. Okay, so let's see what else that we got for this. Minus 3x squared, minus 2x plus 1. Okay, so minus 3x squared. minus 2x, and then plus 1. You guys see that the zeros right in between? Irrational, another irrational, another irrational. So that's why we cannot use the rational zero theorem to find out the possible zeros. So this one you probably want to state that it's from -2 all the way to 4. Okay, so the interval right in between -2 and 4. So this one normally it's a graphing calculator problem, because anytime that the rational zero theorem doesn't work, so that means you need to apply the graphing calculator, either the TID4 or the decimal. Okay, so this one's being bounded in between -2 and 4. Okay, so on the closed interval, -2 to 4. So consecutive integer endpoint, so that means, we're using the integers. And the next one is quite similar. Is there a real number that equals 2 more than its value q? So this one, the real number, we don't know what that is, so let's say that's x. So that equals 2 more than its value q. Okay, so x cubed. So is that possible to have a value of x like this? Well, let's find out. So this one, try to bring everything together to one side. So we do know that it's considered x cubed minus x plus 2. So bring that x from the left hand side to the right hand side. So set that equals 0, and then try to find out the value of x. Again, this one is considered prime, odd number. So this one you won't be able to find out the rational 0. So the 0 will be considered irrational. So again, we're using this one as a function, x cubed minus x plus 2. So let's say that's y. So another calculator problem. So putting this one into decimal and see what happened. So this one we got x cubed. Okay, so let's just set up the new functions. So x cubed. And it's showing that's what, minus x plus 2. So I just want to double check that, minus x plus 2. As you can see that here, the zeros. Well, it's possible to have a real zeros like this, to have a possible real solution. So that number would be -1.521, blah, blah, blah. Again, it's an irrational number. So for those you might be wondering, calculator on decimal here, it's just showing that 3 decimal places. If you try to use that, the TID4, it'll show you more than 3 decimal places. Okay? So try to use that, the TID4 calculator. So type in the functions and then just allocate that 0. Okay, so let me just put it right here for that, the TI-84. Okay, let's see. Or the CE model, for those who do have the calculator like that. Yeah, somehow this one is not showing what I got. Okay, let me just go through this one here. Okay, excuse me for a second. Okay, let me go back to decimal, and then the TI. So check it out. So for the 84, for those of you who have the TI-84, okay, so let me just clear all this. So y equals, again, that one is x to the 3rd power. Okay, so x cubed minus x plus 2. Go to zoom, standard, and then in order to get the 0 here, this one is not like decimal. You cannot just simply click that point. So all you need to do, go to second, trace, hit 0, And now the calculator is asking about the left bound. So left bound, this one is an increasing curve here. So left bound should be everything down below the x-axis. So anywhere that's getting close to the 0 here. Left bound, press enter. And then right bound, press the right cursor a couple times. And then see that's right above the x-axis now. And then click enter. Click enter one more time. So the number right there is negative 1.52138. So on decimal, it shows that 3 decimal places, but for the TID4 or the CE model, it shows that more than 3 decimal places. Okay. So going back to the packet, and the rest of this is all about factoring. So you can either factor by grouping, you can factor by using the smiley face. Okay, so try this. And this one, it's 1, 2, 3, 4, 5 terms, pentanomial. So again, try to group them, factor by grouping, and see what happens. And number 7 is just like what we've been doing. And looks like that one we need to complete the square and find out the vertex form. And then on the same graph, in part A, using the color pen or color pencil, graph that f of x equals g of absolute value of x. Again, if you see that g of absolute value of x, it makes everything even. And then let h of x equals f of x squared. Find a real 0. So look for that. So this one's kind of like a composition function. Okay, so whatever that h of x that you find out. Well, whatever the function that you find out for the previous one. So you just want to put in that x squared. Okay. So the next sections I would like to talk about here, it's the synthetic division, the remainder zero theorem, and also using the synthetic division to find out the possible zeros, things like that. So for the first one, it's a little bit tricky. So let me just nip this one, and then I'll take that to the new slide. If you guys do remember that the long division, the synthetic division is back to algebra 2. So when can we use the long divisions? When can we use the synthetic division? So for the long division is that we can divide any type of divisor. It doesn't matter what kind of divisor that is, linear, non-linear, we can use the long division. But for the synthetic, the divisor got to be a non-linear binomial. So there's a requirement for using the synthetic division. Okay, so the synthetic division, so the divisor, it's always considered a linear binomial. Okay, so now check it out for this one, the first one. So let me open up the new slide here. Okay, so we do know that the dividend is 9x to the 4th power plus mx minus 5. Again, in notation. Divisor, 3x squared plus 2. See that it's non-linear because that's a quadratic. And we do know that the remainder is 5x minus 1. Find the value of m. So basically what this one is saying that 9x to the 4th power plus mx minus 5 divided by 3x squared plus 2. The final remainder is going to be considered 5x minus 1. So we need to find the value of n. And as according to the format right here, the quotient is missing and the process is missing here. Well, let's just perform the long division. So what we got here, so 3x squared. So in order to cancel out the 9x to the 4th power, we need to multiply by 3x squared. So 3x squared times 3x squared, then that'll be 9x to the 4th power. 3x squared times 2, then that'll be 6x squared. And you might be wondering, this one is linear, but the other one is quadratic. Well, don't worry, this one is just subtract. So by the time that we subtract, make sure that you need to rewrite it from the greatest power to the least. Because, well, basically the quadratic and the linear, we cannot combine them. So negative 6x squared, and then plus mx. And then we want to go through the same process again. So this one, 3x squared. So in order to get rid of the negative 6x squared, we need to multiply by negative 2. So negative 2 times 3x squared, negative 6x squared. Negative 2 times 2, negative 4. Okay, so what we got here, it's what? mx minus -4, so plus 4. What about the constant -5? Just drop it down all the way through, minus 5. And we do know that the final remainder, it's considered 5x minus 1. Okay, so check it out. So 5x minus 1 would be the final remainder. So basically this one, just want to combine the constants. So mx, 4 minus 5, -1. So as you can see that here, once you subtract. So mx, okay, minus 1. So once you subtract one of the element, well, whatever that is. Okay, so the final remainder, this one, just want to compare that, because this one is actually the final remainder. So it looks like m is what, 5. Because 4 minus 5, then that would be -1. So bring down the mx. So you just want to set that the remainder equals to mx minus 1. So compare and contrast. So m equals 5. Okay, so this one is kind of tricky. So you need to fill in the blank for the process of the long division, the quotients, and all the remainder that we find out from each step here, and then simply subtract. So got to be careful the sign change by the time you subtract. You know, the way to combine the like terms, because that, for this part right here, a lot of things that's missing here. Okay, so got to be very careful. Okay, so now let's see what else that we have for the other part of the long division or the synthetic division. So number 2, when the polynomial f of x is divided by x plus 3, the quotient is x minus 1. Okay, so here's another interesting one. And the remainder is 2. So this time we want to find out f of x. Okay, so this one, well, it's hard to tell what kind of division that we need to apply for this, whether that's long division or synthetic division. Okay, so we're going to find out. Okay, so we don't know the dividend, so that's missing. That's what we need to find out. So f of x, that's the dividend. And the divisor is given already. It's x plus 3. And the quotient is x minus 1. And, well, the remainder is 2. So we got a remainder, we got a quotient, and also we do have the divisor. So one thing that we notice for the dividend, so let's say dx. So d of x, it's always consider the format of the quotient times the divisor, and then plus the remainder. Okay, so the quotient that's given already, so which is what, x minus 1, and then divisor, x plus 3, and then plus the remainder. So basically using this structure or the formula that we can find out the dividend. Okay. And for those of you not believing this one here, so this one can be saying that it's dividend divided by the divisor. It's always considered the quotient. And then once you subtract, you'll get the remainder. So basically this one, it just consider, well, imagine that the mixed number. So the mixed number is always written as quotient plus the remainder over the divisor. But right now, what we need to do, so we need to figure out the dividend. So the quotient times the divisor plus the remainder, then that'll be the dividend. Okay, so using this structure. Okay, so now let's see what else that we have for this. Again, this one you need to multiply it out, expand it, combine the like terms. So the way that I just put in here, that's just a setup. Okay, so going back to the template. So this one, it's using synthetic division. You guys should be pretty familiar with that. But you gotta be careful. The divisor is a fraction. So the way to find out the number for the divisor, always set the divisor equals 0. So solve for x, you got what? 1/2. But don't forget, after you come up with the quotient, you need to divide everything by 2. Because that 2 or 1/2, it's considered the greatest common factor. Again, it's something that we talk about in Algebra 2 already. So the next one I'd like to show you here would be number 4, factor the following polynomial, f of x completely. So given that f of -4 equals 0, if you try to start it off with p over q, there's a lot of possible rational 0. But one of the 0 is given already. It's -4. Okay, so we can start it off with the synthetic division or using the remainder 0 theorem. So we got 3, 13, 2, and then -8. So start it off with -4. And let's find out the new quotient. So 3, bring it down. 3 times -4, -12. Combine it with 13, so we got 1. 1 times -4, -4. Plus 2, so we got -2. So -2 times -4, exactly 8. So -8 plus 8, 0. So the new quotient, as you can see, that is 3x squared plus 1x minus 2. And then with the original divisor, x plus 4. So that means the rest of this, we can factor it. So x plus 4, factor it completely. So we got 3x, 1x, and then -2. So let's put -2 here, and then positive 1 here. So for those zeros, so we do have x equals -4, x equals 3/2, no, x equals 2/3, and then x equals -1. But this one, you just need to factor it completely. No need to find the zeros. So please don't do the extra work. Okay, so just factor it. So synthetic division with the given zeros already, and then whatever the quotient that you have, rewrite it and then factor. So number 5, so that one, it's also a little bit abstract. So the polynomial, okay, the dividend has x minus 1 as a factor. So 1, that would be the divisor. And when the polynomial is divided by x minus 2, there's a remainder of -10. So find the value of a and b, and now the factor of the polynomial. Okay, so this one is one of the interesting one. Okay, so again, this one, let me just take this to the new slide. So it's pretty much like what we've been doing using the factor or the remainder 0 theorem. Okay, so again, anytime they see the word problem, so this one, it's always indicating a lot of element here. So the one that's given, dividend, divisor, and here's it's another divisor, so we're going to find out, and this one is the final remainder. Well, a and b, those are just constant. Okay, they're not considered variable. The only variable is x. So using that as synthetic division, so we do have 1, -5, a, and b. So nothing missing from the cubic quadnomial. Third degree, second degree, first degree, constant. Okay, or 0 degree. Divisor, x minus 1, set that equals 0, so we're using 1. So bring down 1 first. So 1 times 1, then that'll be 1. Combine them, new remainder, -4 times 1. So -4. So this one turns out to be a minus 4. A minus 4 times 1, a minus 4. And since we do know that 1 is the factor, so that means this one is all divisible. So the remainder for this one is always 0. So one of the equation we can set up here, so b plus a minus 4 equals 0. In other words, a plus b equals 4. So that's just the first brand new equation we just create here. So two constant, unknown constants or variables. So that means we need to set up two equations. So the way to solve for this one is just like recreate the new equation, like the linear system. So we'll be able to solve for a and b. And then continue with the rest of this. Another divisor, so then that'd be 2. Again, set x minus 2 equals 0, so x is what? 2. So continue with that, the quotient. So 1, bring it down. 1 times 2, 2. Negative 4 plus 2, negative 2. So negative 2 times 2, negative 4. And the final remainder for this one, what is it? It's negative 10. So that means the second equation is showing that a minus 4 is plus negative 4, just minus 4. So that equals negative 10. So solve for a. So a minus 8 equals negative 10. So a equals negative 2. So if a equals negative 2, then b equals what? 6. Alright, so solve for a and b. And then we just want to find out the possible factor here. So normally this one, usually the way to divide it, so we just come up with that 1x squared. Going back to this line right here. Minus 4x. Well, a it's already solved. It's minus 2, negative 2. So negative 2 minus 4, negative 6. And this one you probably don't want to factor it. It's non-factorable. Okay, so this one, using the quadratic formula to find out the rest of the factor. So one of the factors, what? Obviously is 1. Well, this one is not the factor because that the divisor, the remainder, it's not 0. So we cannot use 2 as the 0. So it's only 1 so far, and then the rest of this using the quadratic formula. So negative b, so 4 plus minus square root of b squared, 16 minus 4ac. So 4 times 1 times 6, negative 6. All over 2 times 1. So 4 plus minus, 16 minus negative 64. So 16 plus 64, which is 80, divided by 2. So the final solution for the other two 0, then that would be considered plus minus, while 2 plus minus root 80. Well, root 80, that's considered, well, just simply factored it out. So it's what, 16 and 5. So 4 root 5. So 2 root 5 divided by 2. So 3 real zeros, 1 rational, 2 irrationals. Okay? And then for number 8, so that one is quite similar. So when x cubed minus 7x plus 6 is divided by the polynomial h of x, a quotient is x squared minus x minus 6. Okay, so this one is obtained with the remainder 12. Find h of x in the simplest form. So this one is quite similar. Okay, so again, we're using the structure as what I mentioned before. So dividend can be written as the quotient times the divisor plus the remainder. So basically what this one is saying, that x cubed minus 7x plus 6, so that equals the quotient x squared minus x minus 6. And the divisor, it's unknown. That's what we need to find out, which is what? H of x. And then plus the remainder. Okay, so the remainder is 12. Well, one thing that we know this for multiplications, quotient, divisor. So this one is considered associative property of multiplication. So basically we can swap the quotient and divisor. So instead of using this one as a quotient, we can actually use that as a divisor. So by performing the long division, okay, so x cubed minus 7x probably want to put in a 0 here for the missing term because the quadratic term is missing, square, minus 7x plus 6 divided by x squared minus x minus 6. And then it's still the same remainder, 12. So from there, we can figure out what the quotient is. Well, the quotient technically, in this case, is just a divisor for h of x. So again, once you put into the structure, divisor, quotient, by using the properties of multiplication. So what is it? It's associative properties of multiplication. You can swap that divisor quotient. Okay, so simply divide it and find out what that is for h of x. So started with what? X, right? Because x squared times x cubed. X times negative x squared. X times -6, -6x. Subtract, you'll get this one cancel. So negative, negative, positive x squared. Negative 7x minus negative 6x plus x. And then this one, just bring it down, plus 6. Again, final remainder is 12. So in order to get rid of that x squared, so we multiply this one by 1. 1 times x squared, x squared. 1 times negative x, negative x. Okay? And then 1 times negative 6, which is negative 6. So as you can see that this part right here is going to get canceled. Okay, so finish that. So the quotient looks like x plus 1. Okay, so for part 2 of the video, we'll talk about the complex number, okay, the real number, and also the imaginary. So you see that there's like a different kind of a symbol here. So it looks kind of complicated, but we'll get to that. And then we have to do some kind of proof, rationalizing. Again, it's nothing special. It's just like what we've been doing. But the thing is, we just want to put in more in-depth analysis with those type of structure. The polynomial, and then the complex number with the complex zeros, things like that. Okay, so just stay tuned. So I'll post up the other video later. Okay, so thank you for watching the first part of that chapter 3 today. So I'll see you guys next time.